We're on lecture 4, where we're discussing what is called revenue analysis. In this lecture, we're going to look at partly how to differentiate. So we'll do some calculus in here. We'll learn revenue analysis. So we're going to understand terms like total revenue, total cost, and the profit. So to start with, key concepts that you need to learn are concepts of total cost, total revenue, marginal cost, marginal revenue, average cost, average revenue. And we'll discuss the nature of a firm and how to maximize its revenues. We'll also look at warfare, government intervention, what happens when government intervenes in these markets, mainly the perfectly competitive market. To start with, we're going to have a list of terms that we need to understand. We have what we call total revenue. Total revenue is simply the product of the price and the quantity. When you multiply these two, we get what we call total revenue. So for instance, you have item that costs 5 kwacha, and these items are 10. Our total revenue would therefore be 5 kwacha times 10, which is 50 kwacha. So this is what we call our total revenue. Anything divided by quantity is called average. So total revenue divided by quantity is average revenue. So if we had 50, we divide it by the number of items that we have, that 10 items, the average revenue becomes 5, which is usually the price in a perfectly competitive market. All right. Then we have what we call marginal revenue. Marginal revenue is simply calculated as a ratio in the change in the total revenue to the quantity sold. It is additional units that you get from an extra sale. For instance, if your sales were as follows, we have 2, 5, 10, and maybe 20. Our total revenue are these sales that we have. We have 2 kwacha, 5 kwacha, 10 kwacha, 20 kwacha. Addition from one unit to the other is called our marginal revenue. So our marginal revenue in this case is 3 at this point, and 5 at this point, and 10 at this point. So marginal is simply the additional. When you hear the term marginal, we're simply looking at the additional unit, additional revenue. We go to the total cost function. We need to understand that we have 2 kinds of costs that every firm must have, what we call the fixed and the variable costs. Collectively, when we add these two, we get what we call the total cost. So total cost is a function in terms of quantity, which has the fixed and the variable cost. What are fixed costs? Fixed costs are simply the costs which are spent on the fixed factors of production, like machinery and buildings. These are capital expenditure. These costs are also fixed in the sense that they don't increase with output. They are fixed. Variable costs are simply costs that change with volume. The higher the volume, the higher the variable costs. The lower the volume, the lower the variable costs. And so, sometimes you're given fixed costs, you spend 100,000, and each cost will be 20 kwacha per unit. So our total cost will therefore be 100 plus 20Q. So this becomes our function of the total cost in terms of Q. The constant variable here is our fixed cost. The one with letter is variable. So this is how our total cost function looks like. So like I said, average is anything divided by quantity. The total cost has two kinds of costs. We have the total fixed cost and total variable costs. If we divide each of these ones by Q, P will now become an A. Our total cost becomes our average total cost. Our total fixed cost becomes our average fixed cost. Our total variable cost becomes our average variable costs. So this is what we get. So when we divide the total cost by quantity, it's called average total cost, which is simply the total cost divided by output. Output in economics is denoted by the letter Q. So Q is the quantity of output in unit. So like I said, the additional units are incremental units are called marginal. So these costs, when we add additional costs, for instance, our costs were initially 10 kwacha, 15 kwacha, 18 kwacha, 21 kwacha, going on 8 kwacha. So these are called total costs, but the addition from one other unit, for instance, here we have increased by 5, have increased by 6, have increased by 9. These are called marginal costs. So the marginal cost is simply the change in total cost that has been incurred as a result in an additional unit in production. So if you're using calculus, we're differentiating DC over dq. DC over dq. So in our previous class, we had briefly explained how to differentiate the two terms. Y is equal to AX. And when you differentiate Y over the X, we get a differential NA n minus 1. So we are simply multiplying this by that and subtracting 1 from the power. So using an example, if you have 5x to the power 4, differentiating this is the letter this side over the letter that side. The change in y, we use the letter dy over dx. This will give us what? 20 to the power what? 3. Since we are subtracting 1 from there, we are multiplying these two numbers. If we're given in terms of total revenue, as for instance 170 q minus 5q squared. This is called TR over dq. The letter this side is TR. The letter this side is q. We are told that whenever we're differentiating the total revenue, it becomes an M. It's called marginal revenue. So 170q, there's a 1 there. So 1 times 170 is 170. 1 minus 1 is 0. So the q comes off. When you multiply 2 times 10, 2 times 5 is 10. When you subtract a 1 from there, we're going to remain with 1. So this is called our marginal revenue. What if we were given total cost as 10 plus 2q? Likewise, it will be dTC over the what? Over dq. So we said total cost becomes marginal cost. So the T becomes an M. So since we have a constant here which has no letter, it drops out. But 2q becomes 2. Any number with just a letter the power 1 remains that particular number. So in a quick nutshell, differentiating these numbers here, 4Q3, 9Q, 5, 10Q, 100, 8Q2. Let's quickly differentiate these ones. What do we get 4Q3 when differentiate it? What is 4Q3 differentiated? It's simply multiplying that.
12Q squared.
12Q squared. What do we get when differentiate 9Q5? 45Q4. What do we get when differentiate 10Q?
10.
10. What do we get when differentiate 100?
0, nothing.
What do we get when differentiate Q2?
16Q.
Exactly. So this is basically what we call differentiation. Now we are going to apply this differentiation in what we call revenue analysis or optimization. So what have we said? These terms are very important. E stands for what? Price. Q stands for what? Quantity or output. ER stands for what? Total what? Revenue. When you differentiate it, it changes to MR, which is what? Marginal revenue. TR over the Q. When you divide it by quantity, differentiating, it becomes average revenue, which is AR. So MR, marginal revenue. AR, average revenue. EC stands for what? Total what? Cost. MC stands for what? Marginal cost. Simply found by differentiating the total cost of a quantity. ETC, average total cost. Simply found by the total cost divided by quantity. AFC, average fixed cost. Simply found by the total fixed cost divided by quantity. AVC, average variable cost, which is found by the total variable cost over what? Quantity. This pi stands for the profit. Is simply the difference total revenue minus the total cost. When you differentiate the profit with respect to quantity, it's called the what? Marginal profit. Anything marginal and you get it to 0, you're optimizing. Marginal revenue, get it to 0, what are you doing? Maximizing the total revenue. Finding the maximum total revenue. When you equate it to 0, or MR when you equate it to MC, doing the same thing. What are you doing? Maximizing profit, finding the maximum profit. How about MC when you equate it to 0? minimizing the total cost. You don't maximize cost, you minimize them. All these collectively is what we call optimization. So I was trying to explain what these denote. So some calculus again, let's differentiate. TR is 75Q minus 4Q squared. When differentiate it, TR becomes marginal revenue. 75Q becomes 75. 100Q becomes 100. 20Q becomes 20. As long as it's just a number, the letter which is not powered, just maintain that number. Why? Because there's an invisible one there. 1 times that number, 1 minus 1, it comes out. 4Q2 becomes 8Q. So this is called our marginal revenue. Total cost differentiated becomes marginal cost. An invisible one there. So 2 times 1 is 2. And 2 minus 1 is 1. So here we just remain with 2Q. 7Q becomes 7. 23 is out because it is a what? Constant. So let's try differentiate the following. 5Q3 minus 14Q2 plus 8. PC is 1/3 Q3 minus 3Q2 plus 4. So can you lead me through how do we differentiate this?
Yeah, so the first equation, dTR over dQ, this will be marginal revenue, and 3 will multiply with the 5, which is 15Q. The Q cubed will become squared, minus 28Q plus okay, the constant goes off, so it ends there.
All right. Conrad, can you help us differentiate this? PC over Q will give us what? Marginal cost. So 1/3 times 3 is 1. And 3 we subtract 1, what do we get? Q to the power. And here, when differentiate, 3Q2, what do we get? We get a 6Q. This is called a marginal cost. All right, so we go to the nature of a firm and the rule of revenue maximization. So economists is frequently called to help maximize profit, minimize costs, maximize the physical output and productivity, minimize the levels of pollution, and to use scarce resources optimally. So in calculating the profit, which is given by pi, profit is simply given by total revenue minus total cost. So to maximize this, we differentiate the profit and equate to 0. The pi over the q is simply equal to 0. This is how we maximize profit. All right. Similarly, we can simply multiply, we equate the marginal revenue to the marginal cost. I already explained all this. It's another way of maximizing profit. We said profit is simply the difference between the total revenue and as what? Total cost. Profit only occurs when total revenue exceeds our total cost. Otherwise, this is called loss if we get what? Negative. Whenever total revenue is less than the total cost, we go into what we call loss. It is normal for firms to undergo such. So when we differentiate our total cost with respect to quantity, we call it marginal cost. Total revenue with respect to quantity, we call it marginal revenue. When we equate them, that is what we call our profit. Now, profit is simply the point where total revenue exceeds the total cost. At this point here, you see our total revenue is greater than what? Total cost. If you're advising a firm, you produce between Q1 and Q2, because above Q2, we're going to undergo a loss. And below Q1, in the area B, this is a loss. The area between B and C is called the profit. And so the point at which the total profit, total revenue, and the total cost meet, these ones are called the break-even point. These are points where we are neither making a profit or a loss. We're not neither making a profit or a loss. In short, the point when your profit is actually zero. Are we together? All right. So this example here, we've been given our demand function, and we've been given our cost function, which will come later on. So we're told that P is equal to 2Q, 30 minus 2Q. So we're being asked to calculate the total revenue. So since we know total revenue is price times quantity, where there's price, we put 30 minus 2Q. Where there's quantity, we impute it. We are never given the actual quantity. So 30 by Q is 30Q. 2Q by Q is 2Q squared. So this is what we call total revenue. To get the marginal revenue, we need to differentiate this. 30Q becomes what? 2Q squared becomes what? Our 4Q. So how then do we maximize revenue? Whenever the M's are equal to 0, we maximize the revenue. So when we equate this to 0, we're going to have 30 is equal to 4Q. So we divide both sides by what? By 4. So when we divide here by 4 and there by 4, our Q is actually going to be 7.5. So Q will be 7.5. So 7.5 units will maximize our profit, our revenue, sorry. So how do we find the price? We substitute this Q we found here in this function. 2 times 7.5, what do we get? 15. So 30 minus 15, our P is equal to 15. So this is what will maximize total revenue. This is a quadratic equation usually to look something like this here. We have our 0 there and we have our 15. For 15 is 7.5. 7.5 is the one that we just found here, and that maximizes total revenue. So this total revenue here, we can calculate it if you want, since we know that total revenue is price times quantity. Our price is 15, our quantity is 7.5. When we compute that, it can actually give us the actual total profit that is being maximized. Give us the actual total profit that is being maximized. So if you multiply 7.5, multiply it by the 15, you get yourself 112.5. So this 112.5 is the actual revenue at which we maximize. Repeat, you'll be given a function like this. Be asked for 4 important things. Number 1, calculate the total revenue. Total revenue is price times quantity. The price, this whole function, quantity is Q. So 30 times Q is 30Q. 2Q times Q is 2Q squared. You get your max there, 2 max. 2, find the total revenue. The average marginal revenue. Marginal revenue is when you differentiate this function. So 30Q becomes 30. 2Q squared becomes 4Q. Done. You get your max there for differentiating. And they ask you to maximize revenue. So maximizing revenue is when MR is got what? 0. So when we equate this to 0, the 4 goes this side, it becomes a positive. We divide by 4 on both sides, our Q becomes 7.5. 7.5, you put it back in the original price function to get our price as 15. So this is the price and quantity that maximizes total revenue. You get your 3 marks for this. And finally, ask you what is the actual total revenue. Total revenue, you can substitute this Q, 7.5, in this function. Here, put 7.5, 7.5. Or just multiply the two, price times quantity, directly to give you the total revenue at which those are the price and quantity that maximizes total revenue. So let's try to do this exercise together. Please, let's be objective. Given the demand function as follows: 40 minus 2Q. The fixed cost is what? 10. And the variable cost is what? Half Q2 plus 5Q. So already we're being asked to find expressions for total, average, and marginal cost, and total, average, and marginal revenue. So for total costs, we know that total cost is got what? Fixed cost
as variable cost.
As variable cost. Good. The variable fixed cost has been given as what?
10.
Put your 10 there. And the variable cost has been given as what? Half Q squared plus 5Q. In there. So this is total cost. Average cost. What is the average?
Total cost divided by quantity. Total
cost divided by quantity. So you divide each individual by quantity, by quantity, by quantity. So this part here will remain as what? N over Q. This part here will remain as what? Half, but with 1 Q, since the Q's were 2. This last part here remain with no Q. So that's 5. All right. Of course, this one is called your average fixed cost if you want. This one is called your average variable cost. To find the marginal cost, you differentiate the cost function. So we are 10 plus half Q squared plus 5Q. When differentiate this, the 10 falls out. You are simply going to have what? Q. And here we're going to remain with what? 5. So this is what our marginal cost will be. So let's go through. Total cost is what? Fixed cost plus variable cost. This is 10 plus 0.5Q squared plus 5Q. Get 2 marks there. How do we get our average total cost? The total cost over quantity. So here, I advise that you spread the quantity throughout because people have a mathematical error. They'll just divide at one point. So divide by Q here, divide by Q there, divide by Q there. So this will remain with 10 over Q. This will remain with 0.5, but 1Q. 0.5 is the same as half. You can leave it as a fraction, or even a 0.5. The Q here will cancel with that to remain with a 5. How do we get the marginal cost? When we differentiate this and drop, here we have 1 Q. Whenever I write 1, so we're just going to have what? Q. So we're going to have Q there. Here we're going to have 5. So what are we going to have? Q plus 5, which is our marginal cost. So you get your 2 marks there. You get your 2 marks there. Are we following?
Yes.
All right. And we're given our demand function as follows: 40 minus what? 2Q. So how do we find the total revenue? Total revenue is price times quantity. 40 minus 2Q, then we multiply by the quantity. So 40 by Q is 40Q. 2Q by Q is 2Q squared. So this is our total revenue. Average revenue, we divide this total revenue by quantity. Ideally, you can also just divide this part by quantity. Average revenue goes back to the price itself usually. So average revenue will come out as a price, especially for a competitive market. So we get 40 minus 2Q. And how do we find the marginal cost? Our marginal cost will be 40Q minus Q squared, 2Q squared. When you differentiate this one here, it becomes what? 40. Q squared becomes what? 4Q. This becomes our marginal revenue. If you're asked to maximize revenue, you simply put this to 0, and this one goes the other side. So we're going to have 40 is equal to 4Q. So when we divide both sides by 4, our Q becomes what? 10.
10.
This,
10.
and when you put it here, we're going to have
20.
40 minus 20, meaning our P is going to be what?
20. 40.
It's going to be 20. 40 minus 20, which is what?
20.
Which is 20. Are we following?
Yeah. Yes.
All right. So this will be your homework. I will require of you to do it. I need you to maximize our profit. Let me try it, because at what point do we maximize profit? There are 2 ways. You find the total profit.
MRI is equal to MC.
Good. MR is equal to MC. So what is our MR in differentiate this part? MR will be what?
4,000 minus 66Q.
4,000 minus 66Q. Excellent. Here our MC. What do we get when differentiate?
6Q squared minus 6Q plus 400.
What happens to this constant? It drops out. We these 2. All right. We're going to say 4,000 minus 66Q is equal to what? 6Q squared
6Q squared
minus 6Q plus what?
plus
400. Okay. So we put the like terms together. All right. So we want to remain with the 0 this side. So we have 6Q squared minus 66. What is this?
6Q.
6Q. We'll marry it with this guy. When this guy comes here, to add what? 66 what? Q. And plus 400. When this guy comes this side, what will it do?
Minus 4,000.
1,000. All right. So what are we going to have? 6q. When we do this, we're going to get what?
Plus 60
Plus 60
Q
q. And this guy is what we're going to have?
for
Minus what?
3,600.
1,600. Simplify by dividing by 6 throughout. What are we going to have?
Q squared
Q squared
plus 10 Q minus 60 600.
Whenever you reach this point, it becomes a quadratic equation. Now, quadratic equation, I'll take it to your grade what? Grade 5. When you have a quadratic equation, anything equal to 0. For instance, if you have, let's say, 2q squared plus 4q minus 6. This is a quadratic equation. Quadratic equation is given by the form ax squared plus bx plus c, where we use the general formula x is equal to negative b plus minus b squared plus 4ac over 2a. In this case, we need to identify a is simply anything that has a what? Square. So a in this case will be 2. B is anything to the power 1. So b is what? 4. C is a constant. Its sign negative what? 6. What are we going to do here? Negative 4 plus or minus b squared. So 4 squared minus 4ac. Where there's a, we put 2. There's c, we put negative 6 over 2a. Our a is what? A is 2. So here we're going to have negative 4 plus or minus, we have 16. So 8 times 6 is 48. Because of that negative, it became a positive. 48 here. And over 2a. 2 times 2 is 4. So 16 plus 48, what do we get? 64. So negative 4 plus or minus the square root of 64. Everything over 4. Know that the square root of 64 is 8. So negative 4 plus or minus 8 divided by what? The 4. So whenever you have a quadratic equation, you have two answers. So it's either q is equal to negative 4 minus 8 over 4, which is negative 12 over 4, negative what? Negative 3. Or the other could be negative 4 plus 8 over 4. So simply be 4 over 4 to be positive 1. But when you're dealing with quantities, you can't pick a negative quantity, you pick a positive quantity. So if this was our total revenue, the revenue that maximizes would be 1 unit, not negative 3. So in our context, just calculated and got our function as q2 plus 10q plus minus 600. So help me now. Q squared plus 10q minus 600. Help me identify which one is our A.
A is 1.
So 1,
B,
B
10,
10,
and C.
600.
600.
600.
All right. What's the general formula?
Minus B plus minus square root B squared minus 4AC over 2A.
So here, we have what?
Minus 10
Uh-huh.
plus square root 10 squared
Uh-huh.
minus 4 1
Mm-hmm.
minus 600
Mm-hmm.
over 2 by 1.
Mm-hmm. What do we have here?
100
Mm-hmm.
to 4
Mm-hmm.
2
Mm-hmm.
square root 2 5
Mm-hmm. The square root of 2, 5.
50
50.
So what are the two options? Q could either be what?
40.
60
20.
minus
40
60
divided by 2.
So this one is giving us what?
That's
minus
60 over 230.
30
Uh-huh. Then this one.
That's 40 over 220.
So which quantity do we get?
The positive one. Since it's
The positive quantity. All right. So this is amount of quantity that will maximize our profit. Are we following?
yeah
This is exactly what you're supposed to do. When you compute that, this is what he did. You get two values, 80 and 20. So we pick what? 20. So you get your 5 marks for that. All right. They ask you what is the actual profit. You substitute this in the profit function. Give me the value of the profit. So how do we come up with the value of the profit? Profit is total revenue minus total cost. So make sure that you put total cost in brackets because the negative negates the issues there. So we have what? 4,000 minus 1, and this negative becomes and you take the like terms together, you come up with the actual profit function is this one. So when they ask you to find maximum profit, where there's Q, you put 20, 20, 20, 20. Now, the other way of optimizing, we know that we just find the marginal profit and equate it to 0. Remember what I told you, eh? Profit over the what? Q to 0. When you differentiate once, use profit 1 apostrophe. When you differentiate twice, you put exclamation mark. So this is just a shortcut of saying we differentiated once. So minus Q cubed becomes minus 6Q squared. And 30Q squared becomes 60Q. 600Q becomes 600. 5,000 becomes a 0 equals 0. So this one we divide by 6 throughout. We're going to have this equation. All right, when you get it, you do this is completing the square method. Found Q is equal to negative 30 and Q is positive what? Positive 20. So we're going to put 20 as a point that will maximize your profit. The question is, suppose both of them were positive. What do we do? Differentiate for the second time this function. And you equate these two answers. Answer that will give you a negative is one you pick because that is called maxima. I repeat, if both answers are positive, what do we do? Do we pick the bigger one? No, no, no. We differentiate here for the second time. So I exclamation marks. So negative 6 Q2 will become negative 12Q. And negative 60 becomes negative 60. The rest becomes positive. We equate 30 in here, 20 in there. The answer that will give you a negative is what you call the maxima. Called maxima. One that gives you a positive, you don't pick it up. Right. So enough for today. I will end here. I'll give you classwork. Is there any question at this point? Please ask now, or forever hold your peace.
The last explanation, you said when we find two values that are both positive, we differentiate the second time,
Yes,
and when we differentiate for the second derivative,
Mhm.
we have to find we have to go with the negative number.
Value that gives you a negative value of the second derivative. You input this one in there. All right. Start with, these are semifinals. When one is negative and one is positive, automatically disqualify the negative one. We just pick this one because we don't have a negative quantity. Both are positives. We go to the finals. We substitute these figures in the second derivative. One that inputs gives you the value answer, which is negative, is what you pick. What if we both get positives or negative? That scenario is impossible. All right. So I made myself clear.
Yes.
All right. So I'll give you some homework based on what we have just done. Please don't embarrass me. Do a very good job. I will end here.